So I started the recording. I was going blind. So here we go, the outer solar system, and without further ado, we will have a little roll call of what we find there. So obviously, this is the realm that's dominated by the giant planets, 4 of them, Jupiter, Saturn, Uranus, and Neptune. But there are lots of moons to consider as well.
Excuse me, Paul, we can't see your presentation.
Dwarf planets. Oh, I'm sorry, have I forgotten? I've made a mess of it. That's because I got out of order, isn't it? Thank you, Clive.
Okay.
It's all going on at once here. We'll try that again. Can you see it now?
Yes.
Thank you. Right. So the outer solar system. And we have the roll call of the 4 giant planets, Jupiter, Saturn, Uranus, and Neptune there. Lots of moons and many dwarf planets, an ever-increasing number of dwarf planets, in fact, and we'll say more about that later on. But that's not the only occupants of the outer solar system. There's really quite a number of different things to discover out there. Just to give you a sense of the scale, the outer solar system is an absolutely vast region compared to last week, where we were in the inner solar system. This orange ring is the orbit of Mars, and we pretty much stopped at Mars, just mentioned that beyond Mars came the asteroid belt next. The asteroid belt marks the dividing line between the inner and outer solar system. And then we have Jupiter, Saturn, Uranus, and Neptune, and shown on here, the dwarf planet Pluto. And we will be talking about Pluto, actually paying it quite a lot more attention than some of the other objects. So just to have our whistle stop tour, this is planet Jupiter. I took this image from the back garden here in Over with my 14-inch reflector and a webcam. And you can see the great red spot here. Can I get people to put themselves on mute just to keep the background noise down? Thank you. And the lovely cloud belts across north and south of the equator. You can also see that the planet is wider across the equator than it is pole to pole. And that's because it spins very fast indeed. It's a huge planet. You could drop 1,000 Earths into it, but not very dense, only 300 times the mass of the Earth. So a density of about 1/3 as much. But it is 2.5 times the mass of all the other planets put together. So it really does rather dominate things. And as I said, 5 astronomical units, that's 5 Earth-Sun distances from the Sun to Jupiter, and the orbit takes 12 years to go round. Another image, a fantastic shot, this one, not one of mine, of the atmosphere of Jupiter again, with those cloud belts showing some more of the structure. The black dot is the shadow of one of the moons of Jupiter that's passing across in front of it. But I just wanted to say briefly about some of the chemistry out here in the outer solar system. It's so cold out that this far out, away from the Sun, that all of the most volatile gases are able to be trapped and retained by the gravity of the planets, and so they grow these vast gaseous envelopes, 88% hydrogen, 10% helium in the case of Jupiter, with traces of all sorts of other interesting chemicals that some of which are kind of on the way to the building blocks of organic chemistry and life. We've got another animation here of the atmosphere of Jupiter showing that rotation. It only takes just over 10 hours to spin on its axis, despite being such a large object. And what they've done here is pinned the great red spot and used that as the reference point, and then made everything else move relative to it in the sequence of images. And you can see that some of the cloud belts seem to be moving forwards and some backwards. So there's really quite a complicated structure with different bands moving at different speeds. The Great Red Spot itself was first observed by Galileo the first time he looked at Jupiter back 400 years ago with his small telescope. It's quite obvious, and is a large hurricane which has been raging for at least 400 years. Now, from time to time, it's looked like it was going to fade away, and for a little while it became the Great Grey Spot. The image at the bottom there was taken by the Pioneer space probe, series of stop motion pictures. Again, every time the Great Red Spot was in line, they took an image. So you can see that seems to stay more or less stationary, and the rest of the atmosphere moves relative to it. But the Great Red Spot, viewed with a telescope, does rotate around in about 11 hours. And so actually, if you don't see it, then you just have to wait a few hours, 4 or 5, 6 hours usually, and it will reappear from behind the planet and become visible again. We've often wondered what causes the red color right on the tops of the cloud tops of this hurricane. And there was a paper published a couple of years ago that gives the answer, which is it's sunburn. In fact, it's the action of ultraviolet light on the chemicals in the atmosphere of Jupiter that is causing a chemical reaction creating ammonium hydrosulfide, which is a relatively complex sulfur, nitrogen and hydrogen compound, and that is responsible for this red tinge. We're not entirely sure of the internal structure of the giant planets. We think that there's probably a small rocky core, maybe the Earth, same size as the Earth, or 2 or 3 times the mass of the Earth in the case of Jupiter, right deep down in the center, and then a vast ocean of metallic liquid hydrogen overlaying it. We've recently managed to replicate metallic hydrogen under enormous pressure in the laboratory on Earth in a diamond anvil and prove that it can exist. And we're often speculated that that's what is probably going to be in the very high pressure and quite high temperature environments in the cores of some of these giant planets. And then overlaying that, the density gradually decreases to the atmosphere that we can see and study. And indeed, we did drop the Galileo space probe down through the clouds tops of Jupiter and got some data back as it parachuted down until the pressure and temperature crushed the spacecraft. So only a fairly small distance inside, the pressure overwhelmed it. It has a strong magnetic field. That metallic hydrogen spinning around and being turbulent creates the dynamo effect in the same way that the liquid metal in the core of the Earth gives us our magnetic shields. And you do get aurora on the planet as well. This northern lights on Jupiter here, very spectacular, and a different color. You're getting this blue color because of the different chemistry of the atmosphere. On Earth, the green is caused by oxygen. We don't have free oxygen in the atmosphere of Jupiter, and it's mostly the methane that is giving the blue color. Now, on the right here, we have the Discovery image recording in Galileo's notebook, where he found that Jupiter had a small family of moons orbiting around it. They're marked by the little stars either side of the circle, which is the planet itself. And here's a telescope picture I took with a modest size 6-inch reflector telescope of Jupiter with its cloud belts, picking up the 4 Galilean moons as they're known. Io, the closest in. Europa actually is the second closest. It's sometimes deceptive. Ganymede is orbiting round behind Jupiter here in its orbit. So it looks like it's closer than Europa, but it isn't. It's just a matter of line of sight. And then the 4th one is Callisto here. If we look at those with images taken by space probes, you get fantastic detail. We've got most of the whole disk of the 4 of them at the top, and then some zoomed in images underneath. and amazing colors and structures that you can see there. So let's have a look at each of them in turn, starting with Io. Io is the nearest moon and looks like a pizza in the top left-hand corner there, but all of those colors are not in fact cheese, but they are sulfur in different forms. Depending on how quickly you cool sulfur down from its molten state, you get either yellow, orange, black or white forms of it. And you can see those are the four colors that comprise the surface of Io. It is almost entirely covered in sulfur, and the black things are volcanoes, volcanic calderas, spewing lava out onto the surface. We've zoomed in on one of the calderas here, and you can even see the rivulets of lava running across the surface. This is a backlit image where the sun is partially behind the direction of sight, and so it's causing a plume of material here to be illuminated above the surface of Io. And this is an active volcano called Pele, named after a Hawaiian god, not the footballer, that's erupting off the surface. And again, here we have Pele erupting, but this is not the only eruption that's going on. There's another one there, look. And if you look closely, there's another one there, there's one there, and there's one there. So there are at least 5 active volcanoes on the surface of Io caught in action there in that one shot. It's the most volcanic place we know. Moving out, we get to Europa, about the same size as Io. They're both about the same size as the Earth's moon. And Europa is fairly shiny, but covered with these grooves, these brown stained grooves that seem to cut across what looks like a very icy surface. Just one fairly significant impact crater there, and perhaps another one there, but the rest of it is largely, again, devoid of impact craters, so looks nothing like our moon, despite being relatively similar mass and size. And we think what is going on is that there is an internal rocky core overlaid by a mantle and then a thick ocean of liquid water, salty, briny water, covered by a very thick outer coating of ice, where the water would have been frozen by being exposed to the cold of space. Almost no atmosphere over the outside of that, so nothing to keep the cold away from the surface. So the ice is probably 10 to 50 kilometers thick, but nevertheless, it's got these cracks and grooves, and they seem to be bringing up these brown stained chemicals from beneath. And I'm fairly sure that these are going to turn out to be organic in origin. And it's all pointing to the fact that there are probably biological processes active today in the oceans of Europa underneath. So we are talking alien life forms in this ocean, I think. I can't prove it. We will have to go there and sample exactly what is going on the surface and try to penetrate through and maybe drop a submarine or something into the oceans of Europa. Amazing fact, there's actually more water on Europa than there is in the whole of Earth's oceans by a factor of 2. So deep there are they. Then we get Ganymede. Ganymede's the largest moon in the solar system. It's actually larger than the planet Mercury and may also have layers of liquid water in its interior in the same way. And the interesting question is, what is stopping these moons being completely frozen? They're fairly small, and something is keeping their interiors very warm. Small planets and small worlds like this should lose their heat to space like Mars has done and freeze up their interiors and be solid rather than having any liquid water or anything. So they should have lost all of their heat because they have a smaller volume compared to their surface area, as do small children. If you take a small child out on a cold day, it will need a coat very quickly, whereas you can cope for a bit longer. And the reason turns out to be a tug of war between the 3 moons and the giant planet Jupiter, illustrated in this little animation at the bottom here. The inner moon, Io, is whizzing round, and you'll notice every other time it gets to the top, it meets Europa. So there it met Europa, and the next time round there was no one home, and then it met Europa again. If you watch it, nobody there, Europa, no one there, Europa. Now if you watch Europa, the second one, it does the same thing with Ganymede. It's going to catch Ganymede at the bottom there, go round, get to the bottom, nobody home, get to the bottom again the second time, it catches Ganymede. And that 2-to-1 ratio, or 4-to-2-to-1 ratio, causes their orbits to keep getting the same kick in the same direction, and puts them into elliptical shape orbits, which carry them nearer and further from the giant planet. And that creates a tidal stretching and squishing effect caused by the differential gravity of Jupiter as they approach it and then move further away. And that pummeling that they get from that tidal stretching causes the friction in the interior and warms them up and stops them freezing. The 4th moon, Callisto, takes no part in this tug of war. It orbits a bit further out and is not in an integer relationship. It's not in a 2-to-1 relationship with Ganymede or any other simple relationship. It's kind of doing its own thing. And the result of that is it has indeed not got that heat source from the tidal stretching and has completely frozen up and inside, and has no volcanic activity recovering the surface. And that results in it gradually accumulating more and more craters, as you can see, and in the exposed surface being darkened by the effect of the solar wind. The solar wind darkens down exposed rock over time, and that's why the older regions of our moon, the mare, the very old crater impact zones, are very dark when you look at them compared to the fresher craters which look bright. Same thing going on here on Callisto. Now Jupiter also has a set of rings. We didn't really discover them until quite late. I think they were discovered in backlit images from the Voyager probes. So they're not really visible from Earth, and they're quite close into the planet. They are inside the orbit of Io, and in fact there are a few little moons, tiny potato-shaped captured asteroid type moons, Amalthea, Ad Astrea, Metis and Phoebe, that are orbiting around in the ring zone and keeping the structure of the rings going. There's a little picture of Amalthea, the largest. This is the 5th largest, in fact, moon of Jupiter, and it orbits inside the ring zone here. Then we've got the 4 large moons, and then exterior to Callisto, orbiting around Jupiter, it's got, I don't know how many, I think there are 79 total moons at the last count, orbiting round in this completely chaotic 3-dimensional set of orbits. And these are probably, or almost certainly, captured asteroids. Quite a few of them even go round Jupiter the wrong way in retrograde orbits, as we would call it in astronomical terms. And so are almost certainly asteroids from the asteroid belt that wandered too close to Jupiter, got caught up in its gravity. Also associated with Jupiter, there are some Trojan asteroids. So here's Jupiter, here's the main asteroid belt between Jupiter and Mars, but leading and trailing Jupiter on its passage around the sun, it's got asteroids that it has herded into these zones 60 degrees ahead and 60 degrees behind. And these are semi-stable orbital positions. They will eventually probably drift away from these, getting perturbed by the influence of other giant planets. But that's a relatively stable position for them, controlled by the gravity of Jupiter. And most of the large planets have these little families of Trojan asteroids. Now, if we move on out to Saturn, slightly smaller than Jupiter, you can see the figures there. I won't read them all out. Takes 30 years nearly to orbit round, and actually that's in a 5-to-2 relationship with Jupiter. So for every 5 orbits of Jupiter, Saturn does exactly 2, and that's what keeps them stable and keeps most of the solar system in some sort of order, controlled by the relative orbits of the 2 giants, Jupiter and Saturn. But of course, it's most famous for the rings that you see in this marvelous picture, and a little bit of structure on the cloud tops with these rather more muted tones than Jupiter. It also has a magnetic field, pointing again to that same sort of internal structure to the planet, with liquid metal, liquid hydrogen in the center, and creates the aurora again with that same blue color, indicating methane in the atmosphere is responsible for it. A rather curious thing that was discovered by the Cassini probe that flew over the pole of Saturn is this giant hexagonal feature in the atmosphere. This is 6 small hurricanes orbiting round the central rotating zone right at the pole. And that's a relatively stable hydrodynamic structure and seems to persist for quite a long time. We've done mathematical simulations of it. It was a little bit of a surprise to see it though. And again, there's a fantastic color picture of the polar hexagon from Cassini, and some fantastic images of the real detailed structure in the cloud tops. And Cassini plunged into the clouds and parked itself interior to Saturn for tidiness reasons. They decided to dispose of the spacecraft by throwing it into the atmosphere of Saturn. So they got some very good close-ups just before the probe died, but nevertheless got rid of it. And the reason for that was they didn't want it to crash into any of Saturn's moons. I'll explain why in a moment. And then as Cassini passed behind Saturn, it took this fantastic picture here. The sun in eclipse behind Saturn, blotted out, but the rings forward scattering the stray light, showing just how complex the structure of the rings are, and how there are these extra thinner rings and bands around the outside of the main rings that you don't normally see. And there's a pale blue dot just there, and that is planet Earth, just being shown through one of the dusty rings. An amazing shot. The rings are very thin and composed of all these separate little tiny ringlets, and often there are little moons orbiting around inside the ring zone that are keeping the little dusty and ice chunks that make up the rings in order. And here's 2 of them, Prometheus and Pandora, one orbiting inside this set of rings towards Saturn and one just outside of it. And these are shepherd moons, as they're known, and they keep the ring particles in order. You can see how their gravity is creating these ripples and disturbances in the rings themselves. And here in this picture, on the external edge of the ring structure, we think there is a new small moonlet, a shepherd moon, forming, creating this little blob here as gravity is gradually accumulating more material. So a new moon is being born out of some of the debris around Saturn there. Saturn's got a family of moons, and they are perhaps some of the most interesting, along with those of Jupiter. In particular, this one, Triton, again, about the same size as Ganymede, about the same size as the planet Mercury. It has an atmosphere that's 50% more dense than our own, and we have a job to see through it. This picture was taken using infrared to try to see through the cloud, and we can just about begin to maybe make out some surface detail through the hazy cloud-filled atmosphere. But the other three pictures, this upper right one was taken with radar that is able to penetrate the clouds. And these two are taken from the Huygens probe that was dropped and parachuted down through the clouds. A couple of mountains with a valley between them, and you can see what looks like the branching structure of rivers in the valley. And then the probe parachuted down and landed about here in this this zone, just on the edge of the mountains, on what looks like a beach covered in pebbles or a dried up riverbed. We're not quite sure. But the pebbles are made of ice, as are the mountains, water ice, and the rivers that are running across the surface here are made not of water, but of liquid methane. The temperature is minus 160 degrees on Titan, and so liquefied natural gas that we would cook with here as a gas, but it's a liquid at these temperatures, is creating these rivers. And this is the Kraken Mare, a large lake. Again, you can see the rivers, the river channels running into it, and islands within the lake. If we look at some further details of Titan, we've seen rain clouds moving across and blowing around. So there's active weather systems. Again, the rain is not water, it is raining liquid methane. And that rain runs down the rivers into the large lake, again, Kraken Mare here. And if you look at this inset region here, we've got 4 different images taken at different times, moving from year to year. The first one shows that same image, and then it's changed here. But if you look at it, you can still see the same structure is present. It's just some of the liquid has gone and been replaced by land. This is the seasonal level changes in the lake as the methane evaporates back into the atmosphere during the summer on Titan and then rains back, and the level of the lake goes back up again during the winter seasons. Again, more clouds and other lakes all over the surface here. This was a very recent image released by NASA. Moving on, we have another very interesting moon, Enceladus. This picture here shows the surface covered in what looks like icy deposits, but they're very much a surface of 2 halves. This upper region has got craters on it and therefore has been unchanged for a while, so that the number of craters has gradually increased as small space rocks have crashed into it, leaving their impacts. But the region at the bottom has no impact craters, and so is being resurfaced all the time, and the impact craters are happening but being rubbed out again by new material being deposited on top of them. And these blue grooves here, they coined the term tiger stripes for them. I'm not quite sure, since tigers are not blue and white, but that's what they call them anyway, are cracks through an icy surface, just like Europa, leading down to a salty, briny ocean in a protected habitable zone beneath the ice crust. And the cracks are venting something into space. These 2 images, the bottom one in more or less normal color and the top one enhanced in false color, show a plume of material aligned with the tiger stripes emanating into space. And the spacecraft flew through it and proved that this was in fact water, but it was water containing organic material, so carbon, oxygen, hydrogen compounds, and indeed molecular hydrogen. And that is a very interesting combination, because the two together are not really compatible unless something is continually making these compounds. And it's highly probable, I think, that we have some sort of life going on in this protected habitable zone, perhaps feeding on the chemistry of the rock and being able to use that in combination with the water and releasing the molecular hydrogen as a waste product and building complex organic molecules in the process. So another world that we need to go and study in more detail. The number of moons, again, is up to about 70 or 80 moons around Saturn. I haven't got time to cover them all. I'll just show you this one, Iapetus, which has a very curious structure. It looks like someone has cut it in half and then joined the two halves together badly. There is a ridge running around the equator and some frosty deposits on one surface. This, we think, is because this edge, or this zone of Iapetus, is the leading edge as it traverses its orbit around Saturn, and it picks up material that's fallen from the rings onto Iapetus, and so you see the frosty icy deposits. And we think the ridge may be a collapsed ring system. So maybe Iapetus once had its own set of rings and the material has fallen out along its equator and created this ridge. But there are other explanations. We don't really know. If we continue on out, we get to the third of our giant planets, Uranus, rather smaller. These two, the Uranus and Neptune, go by the name ice giants rather than gas giants, because they contain a lot more of the icy compounds like water frozen up and methane and ammonia. And that gives them this characteristic sort of bluey green tinges. So just 4 times the size of the Earth and 14 times the mass, and orbits in 84 years. This was a Voyager 2 image taken and really doesn't show any features at all, rather boring in fact. So we'll move on. It was of course discovered by the famous astronomer William Herschel from his back garden in Bath, and when he first spotted it he thought he'd found a comet, but on tracking the orbit and getting follow-up observations he realized he was the first person in modern times to discover a new planet. We've got a little tiny image of it there taken through my telescope, just a pale green disk. In false color, and again from Voyager, you can discover that it's tilted over on its side and has its own set of rings around it, plus some active storm systems that are just about made visible by the false color. Now this tilt over on its side is very peculiar. It sometimes means it rolls along its orbit with the pole pointing, either the north or the south pole, pointing straight at the sun, and at other times the orientation is at right angles to that. So the seasons on Uranus must be very peculiar indeed. But after its discovery, tracking and working out its orbit started causing problems. People were unable to predict where it was going to be more than a couple of years ahead, kept wandering off course. And this was very curious. And 2 astronomers took up the challenge of trying to figure out what was going on. John Couch Adams here in Cambridge, and in Paris, Urbain Le Verrier. And they both had the same idea independently, that maybe there was an as yet undiscovered planet using its gravity to pull Uranus off course. And they then attempted mathematically to back calculate by hand, no calculators or computers in those days to help them, where this planet might be. And both made sets of predictions. Adams, as you can see, made a number of calculations and produced a number of different positions over a period 1845 and 1846. And they were not spread out over a vast region, sort of vaguely concentrated around here. Le Verrier made his one prediction in 1846 just here, and the planet was found just here, and that planet was Neptune. About the same size, a little tiny bit smaller than Uranus, but slightly more massive, 17 times the Earth's mass, and orbits around the sun once every 165 years. So in fact, since its discovery, it completed the first orbit just a couple of years ago. Great dark spot here, very similar to the great red spot on Jupiter, a large storm system that seems to be persistent and sticking around for a very long time, and some high clouds. It spins quite fast, and the wind speed on Neptune is over 1,000 kilometers per hour. So it has some of the fastest winds in the solar system. The real star of the show at the Neptune system and the unexpected discovery was its large moon Triton. We knew about that. It was discovered only a couple of weeks after Neptune was found. But the close-up image from Voyager 2 here shows amazing terrain and an active surface. Again, no impact craters visible. Therefore, this surface is young and dynamic and constantly being refreshed to rub out the craters. Up at the top here, we have this sort of melon fruit surface, the cantaloupe terrain with amazing grooves. And then lower down here, we've got what looks like pink snow on the surface, and that is frozen nitrogen. This sort of temperatures out in the deep freeze of the solar system here. We're at minus 230 degrees centigrade. And nitrogen, the gas around us that we're breathing in the air around us right now, freezes out onto the surface as this pink snow in these conditions. But there are all these black marks, and these black marks, if you look at them, they're elongated and they're all pointing the same way, this way. And this is because they are the dark, dusty material being deposited downwind in the thin atmosphere made of nitrogen that covers around the globe on Triton and blows in this direction. The prevailing wind is around this way. And what's happening is that we have geysers of liquid nitrogen. So the frozen nitrogen is being melted by some source of heat and bursting forth and then vaporizing into a geyser and carrying dark, dusty, black material downwind and depositing it on the surface. And that black material is very intriguing because, again, this is suggestive of some interesting chemistry. Who knows, maybe these pockets of liquid nitrogen are home again to some form of biochemistry going on out in the deep freeze, 3 billion miles from the sun, out in the outer reaches of the solar system where nobody would have expected it. And so from here on, beyond Neptune, of course, we have Pluto. And I'm just going to switch over to a slide set all about Pluto now. So I'll just halt this one here and quickly go and find the correct